Okay, class, welcome to the next math lesson in 8th grade Eureka Math. We are still in Module 4, and today we're working on Lesson 11 called Constant Rate. Here it is right here. So it's on pages 105 through 121 in your Module 4 workbooks. A lot of pages because this lesson takes up a lot of room, not because there's a lot of work, but because the work is a lot of charting and graphing, which just uses more paper. So don't be scared by the number of pages. If you liked lesson 10, today's going to be a lot like lesson 10. So it's all about constant rate, which is our vocabulary word for this lesson. And we had the vocabulary word for lesson 10 also. So again, the constant rate means a change that stays the same over time. So it's something that is always a change that is always the same. So for example, you can trade 4 quarters for $1 always. That's constant. It stays the same all the time. It's a constant rate. A car going 30 miles per hour, if that is its constant rate, it is always going 30 miles per hour. It does not slow down. It does not speed up. Its speed is constant. If your hair grows 1 inch a month, the constant rate is 1 inch every month is how much it grows. So it's just something that changes, but it changes the same way over a period of time. And time is probably the important thing because every question we have today is going to involve talking about time. So that's our vocabulary word. Should have been pretty quick to write down as there's only one of them. Let's look at what we're doing today. Today, we will write, chart, and graph constant rate equations to solve problems. So we're going to this is actually the 3 steps of what we're going to do today. We're going to write an equation like we learned how to do in lesson 10. We're going to chart an equation, which we got introduced to in lesson 10. And the new thing for today, graphing the constant rate equation. So this lesson is really close to lesson 10. So I hope you finished lesson 10 and understood it and asked all your questions then, because knowing lesson 10 will really help you on this lesson 11. So we're going to write, chart, and graph constant rate equations to solve problems. And as always, I do give you an example. And the example we're going to talk about today is we're going to do 2 examples. They're on pages 105 to 106 in your workbook. So no need to get an extra piece of paper for examples. The examples are on the first couple workbook pages we're going to do together. So that's the vocabulary. That's our goal for today. And there's the example line. If you did not get all that copied down, pause the video, go back, copy down, finish your notes. And when you're done, when your notes are complete and you're ready to work, come back to this part, resume the video, and work with me going to the example on page 105. And there it is, example 1 on page 105. It says, Pauline mows a lawn at a constant rate. So Pauline is mowing a lawn, and she does it, and her speed of mowing is constant. It stays the same. Remember, we need to see that there's a constant rate. These equations only work if we have a constant rate. If we have a variable or changing rate, this does not work. So make sure it says constant in your questions. So she's mowing at a constant rate. Suppose she mows a 35 square foot lawn. 35 square foot. If you want to know how big that is, 35 square feet is probably close to about the size of your bathroom. If you have a bathroom with a tub in it, 35 square feet is probably pretty close to the size of that. So she mows that much lawn in 2.5 minutes. So the question is asking what area in square feet can she mow in 10 minutes? And how much can she mow in T minutes? So there's 2 parts of this. Let's start with just in 10 minutes. So let's find out 10 minutes. Well, to do this, we need to know what her constant rate is. What is her speed? Well, her speed, remember, a rate is amount divided by time. So amount divided by time. Well, we learned that her amount is 35 square feet in 2.5 minutes. So her constant rate is 35 over 2.5. That's her C. The C we want to know is how much, what area in 10 minutes. So this is what we know right here. What we want to know is we want to know in 10 minutes. So the amount is unknown. So let's use the variable y. And the time is 10 minutes. So this is the rate we know, 35 over 2.5. What we want to know is y over 10. Y over 10. And because it is constant, we know that this speed and this speed are equal. It's a constant rate, so this rate of mowing and this rate of mowing are equal. What we know is equal to what we want to know because it has to be constant. So because they're constant, we can put them equal to each other. So we take both our fractions, make them equal, and that gives us a proportion that we saw in lesson 10. Now remember, to solve this proportion, to find y, we use the multiplication property of equality and multiply the denominators of both fractions by both sides. So on the right side, we do times 10 times 2.5. And on the left side, we do times 10 times 2.5. Using the multiplication property of equality lets us cancel the denominators. 2.5 gets canceled on the left. 10 gets canceled on the right. So what do we keep? We keep 10 times 35 on the left, and we keep 2.5y on the right. I'm going to multiply it out. 10 times 35 is just 350 equals 2.5y. Well, remember, we want to isolate y, get it all by itself. So to do that, we do 2.5y divided by 2.5, which is 1y. But the division property of equality tells me if I divide by 2.5 on this side, to stay equal, I need to divide by 2.5 on that side also. So now on the right side, I keep the y. On the left side, I have to do 350 divided by 2.5. Well, let's type that into the calculator. 350 divided by 2.5 is 140. So that means y equals 140. So in the context of my question, remember we're asking what area in square feet can she mow in 10 minutes? So the answer is Pauline mows 140 square feet in 10 minutes. That's the answer to the first part of our question. Now, the answer to the second part is first, this is what we did in lesson 10. You recognize this solving for lesson 10. The next part of the question is saying how much she mows in t minutes. So again, this is like what we did in lesson 10. We take what we know. What we know stays the same. What we know stays the same. But this time what we want to know is how much she mows, what is y, and in this time we're not talking about 10 minutes, we're talking about t minutes. So this time our constant rate is y divided by t. So just like before, what we want to know and what we know are equal because it's a constant rate. So I can take the fraction we know, the rate we know, 35 over 2.5, and put that equal to what we want to know, which is the rate of y over t. And again, what I do to solve this, I multiply both sides by the denominators. And that lets me cancel the 2.5 on the left side, cancel the t on the right side. So I get 35t equals 2.5y. And remember, when we write an equation, we just want it to be y equals something. So to isolate the y, again, I divide by 2.5. But the division property of equality tells me to divide by 2.5 on the left side also. So what I get is I get y equals 35 divided by 2.5 t. So let's do 35 divided by 2.5 gives me 14. Oh, yep, 14. So I get 14t equals y. So how much does she mow in t? So this tells me in t minutes. This is the equation I can find for t for any minutes. So for any minute, I plug it into this equation, and I know how much she mows. So this is the equation I have, which is also what we did in lesson 10. We solved a problem and we learned how to write an equation. Solved a problem and learned how to write an equation. So she mows 140 square feet in 10 minutes, and this is the equation we can use for any number of minutes you can think of. This equation will work for any minutes at all. Now, the new thing that we're going to do today is we're going to use this equation, y equals 14t, and build a chart. And we're also going to graph what we make in the chart. Now, when we make a graph, what we need to do before we graph is our chart comes before our graph. So we're going to build the chart, and we're going to use the chart to make a graph. Okay, so what we're doing is we're doing the y equals 14t, and we're using that equation in this chart. So let's pick some values for t. How much time do we want to say she mowed for? Well, to do this, I'm going to kind of look at my graph that I'm going to make later and see what time options they have for me. So I see 0, 1, 2, 3, 4, 5, 6, and 7. So what I'm just going to do is I'm just going to pick some times that are already on the graph. So let's start with 0, because 0 is always a good value to graph on the x-axis. Let's do 1, because that's easy. Let's do 2, and then I'm going to skip and do 4, and then I'm going to skip to the end and do 7. Now you can actually pick whatever numbers you want for this, because everything will always work, because this equation works for any t you can think of. So y equals 14t. For this one, for the first t was 0, so we do y equals 14 times 0. So y is going to be 0. For t equals 1, we do y equals 14 times 1, which is just 14. When t equals 2, we do y equals 14 times 2, we get 28. For t equals 4, we do y equals 14 times 4, and we get 56. For t equals 7, we do y equals 14 times 7, and we get 98. So now we have t's and y's using this equation. The next step after this, we have our chart. Before we graph, we need coordinates. We need to actually have a list of coordinates that we're going to graph. So what we're going to do is we're going to take this chart and we're going to turn it into 5 coordinates. Now, a coordinate, remember, is parentheses x, comma, y, end parentheses. That is how coordinates are written. Now, for this equation, we don't have an x. We're using t on the x-axis. So t means the x, and y means the y. So let's make our chart. When we have a 0 for the t slash x, we have a 0 on y. When t and x are 1, y is 14. T and x is 2, y is 28. When we have a 4, we put a 4 in, we get a 56. And when we put in 7, we get 98. Now we have 5 coordinates. We can put them on our graph. So remember, this is the x, this is the y, this is t, this is y. So 0, comma 0 goes right here where 0 meets 0. 1, comma 14 goes 1 on the t, 1 on the x-axis. 14 on the y-axis, which means here's the 15. So 14 is going to be a little bit lower. So we're going to go about right here. 228 means we go 2 on this axis. And here's 25, here's 30. So 28 is going to be about right here. 4 comma 56. So we go 4 on the t, and here's 55. So 56 is going to be a little bit higher than the 55 line. And that is our graph. We're not going to the last one because 7 is 98, and 98 is way above the graph. So we don't have room to put that one on this chart. So maybe we should have picked something like 3 or 5, because 7 won't fit on our graph. But you know 7 is probably going to be 7 is 98, like it says right there. So it's probably going to be somewhere up here in the middle of the question for example 1. So let's summarize what we did for this example, because there is a few steps. Some stuff from lesson 10 and some new. So we start with finding what we know. The constant rate, it tells us 35 and 2.5. We use that first, that constant rate, to find out how much she mows in 10 minutes. Then we use this constant rate to find an equation for how much she mows for whatever we want, for whatever time we want. This equation works for everything. And then we turn to the equation. Next step, we turn the equation into a chart. This is what's new in lesson 11. In lesson 10, we did this part, we did this part. In lesson 11, the chart is new. Turning the equation into a chart is new. And then when we had the chart, we turned the chart into coordinates, and then we changed the coordinates into a graph. That's what we're doing today. We are finding the rate you know. You are building an equation. You are making a chart. After you make the chart, you find your coordinates. And the final step we're doing today is graph. So that is those the 5 things we're doing. That's example 1. Take a minute, go back over your work, look at example 1, see how you did. And we're going to move on to example 2, which is pretty much the same thing on page 106. So let's go to page 106 and see how that example looks. In example 2, you can see we're not talking about Pauline mowing yards anymore. We're talking about water coming out of a faucet. So it says water flows at a constant rate out of a faucet. And that constant rate, remember, is important. That constant rate tells us we can make a linear equation. We need a constant rate if we want to make a linear equation. So the rate is constant. We can make a linear equation with it. And then it says, suppose the volume of water that comes out in 3 minutes is 10.5 gallons. How many gallons of water come out of the faucet in T minutes? In T minutes. So let's start with what we know. We know the rate is going to be an amount divided by time. That's a rate. So we know that this rate is going to be 10.5 gallons over in 3 minutes. That's what we know. 10.5 gallons in 3 minutes. What we want to know is how many gallons in T minutes. So we need to come up with, so we want to know this C. So we need to know gallons, how many gallons in amount of time. Now, because we don't know how many gallons are in the time, for time, we're going to use T. For gallons, if we look at the chart gives us a clue. They want us to use V for gallons. So we're going to talk about the volume of water in time. So we know in 3 minutes we get 10.5 gallons. In T minutes, how many gallons do we get? Well, to do this, we're going to need to find that equation. It's a constant rate, so we need to find the linear equation. And you remember from lesson 10 how to build that equation. You take both rates, both ratios, and because they're constant, they are equal. So make them equal. 10.5 over 3 equals v over t. And again, to change this into a more friendly linear equation, multiply both sides by both denominators. Use the multiplication property of equality. Because if you do that, it cancels the 3 denominator on the left and the t denominator on the right. So we're left with 10.5t equals 3v. 10.5t equals 3v. But for our equation, remember what we really like is really just like one variable equals. We want to have v equals something, v by itself. So we do 3v divided by 3 to get 1v. But the division property of equality tells me I need to do 10.5 divided by 3 also. 10.5 divided by 3 is 3.5 right there. And don't forget the t. So we have v equals 3.5t. That is the equation we're going to use to find any answer about this faucet. If you want to know how much water comes out of the faucet in 5 minutes, you put a 5 for a t. In 15 minutes, put a 15 for a t. In 42 minutes, put a 42 for the t. This equation works with any time and any amount of water. That's why we like linear equations, because they can be used for multiple things. So we took what we know, we've thought about what we want to know, we built a proportional relationship, solved it to make a linear equation. Now the next step you'll remember, we're going to build a chart. So in the top of our chart, let's write the equation again. V equals 3.5t. And this time they gave us the t's that they want us to use. So we don't get to have as much fun because they gave the t's they want. So for when t equals 0, we do v equals 3.5 times 0. When v equals 1, we do v equals 3.5 times 1. When v equals 2, we do v equals 3.5 times 2. When v equals 3, we do v equals 3.5 times 3. When t equals 4, we do v equals 3.5 times 4. So we substitute all these, and we have we have the same equation that we need to solve 5 times. First one's pretty easy because 3.5 times 0 is just 0. So in 0 minutes, we get 0 gallons. In 1 minute, we get 3.5 gallons, so 3.5 times 1. 2 minutes, 3.5 times 2, we get 7 gallons. 3 minutes, if you're paying attention, you don't even need to do math because they told us in the question that 3 minutes is 10.5 gallons. So 3.5 times 3 is 10.5. And in 4 minutes, 3.5 times 4 is 14 gallons. So that is our chart. Next step, after we have a chart, we need our coordinates. And this time the coordinates are going to be t comma v form because t is on the x-axis, v is on the y-axis of our graph, t and v. So we do t comma v. And we just make a list of the coordinates that we need. 0 went with 0. 1t made 3.5v. 2t was 7v. 3t was 10.5v. And 4t was 14v. And that is our 5 coordinates. So we took what we know. We made a ratio for what we want to know. We put them equal to solve and find an equation. We used that equation to finish a chart. We used the chart to find coordinates. Now we use the coordinates to graph. So 0, 0 is 0 on the x, 0 on the y, right there. 1, 3.5, 1 on the x-axis, 3.5 on the y. 2, 7 is 2 on the x, 7 on the y. 3, 10.5 is 3 on the x, 10.5 on the y. And 4, 14 means we do 4 on the x, 14 on the y, right there. And that is your graph. You just need to put the points on your graph right there. So your chart should look like mine, your coordinates should look like mine, and your graph should look like mine. And we can use that graph to answer any number of questions. But this is the beauty of building a linear equation. It lets you solve problems before you even know what the problem is. If you have the equation, you know all you have to do is when you get the time, just put it in the equation. That's why linear equations work very well for constant rate problems. But those are our two examples that we did together. What I'd like you to do now is go back and look at the examples a little bit. Make sure you're up to it. Make sure you know what you're doing. And then after you feel confident, go to page 107 and 108 and 109, because on page 107, 108, 109, and even on page 110, there are 4 pages of exercises. Now I say 4 pages, but those 4 pages are actually only 3 exercises. Remember, the graphs take up, the charts and graphs take up a lot of space. So it might be on 4 pages, but it's only really 3 exercises. What I'd like you to do now is pause the video, go back, try to solve these exercises on your own. Try to solve all 3 of them on your own. If you get stuck, you can come back and watch the video and I will help you. Or you can write me an email and ask for my help. But if you do your best on these exercises, you can unpause the video and then check your work when I solve these exercises with you. So try your best to do these 3 exercises on your own, and then come back and check your answers when you are ready. Okay, so hopefully you took some time to look over your examples, to look over, maybe rewatch a little bit about what I did, or maybe send me some questions. And hopefully you also took some time to do the exercises on your own. Remember, there were 3 exercises on 107, 108, 109, and 110. Now you're ready to check your answers with mine. So here, let me explain the exercises and we'll see how well you did on yours. So number 1 says Juan types at a constant rate. Remember, constant rate is important. That lets us do linear equations. He can type a full page of text. That's 1 page in 3.5 minutes. We want to know how many pages P Juan can type after T minutes. Okay. So how many pages? We need to make an equation for how fast Juan types. And then part A, write the linear equation into variables. So we need to make an equation for how fast he types. When we make an equation, we start with what we know, and we know he does 1 page in 3.5. They did 3.5 fraction. I'm going to do it I'm going to do a decimal. 1 page in 3.5 minutes. That's what we know. What we want to know is how many pages P in T minutes. So pages in time. We know 1 page in 3.5. We want to know pages in time, P over T. Well, remember to solve this, he does a constant rate, so his speeds are equal. So these have to be equal. And we use the multiplication property of equality to do T times 3.5 to both sides. Lets us cancel the 3.5 on the left and the T on the right. So we get 1T, which is just T, equals 3.5 P. T equals 3.5 P. But what we really want to do is we really kind of want to do we really want to do P, because pages is going to be our answer. In time, we want to isolate P. Because remember, T is the X variable. T is what we call the independent variable. So we want to get the P by itself. So we do divide by 3.5. And on this side, we're going to do 1 divided by 3.5. So what we end up getting when we do 3.5P divided by 3.5P, we get P. And 1 divided by 3.5. 1 divided by 3.5 is going to be, let's just do this on the page, on the calculator. 1 divided by 3.5 equals 2/7. It does. It's 2/7. We just flip 3.5 over. So P equals 2/7 times T. That's what we get in the fraction way. So that's the equation that we have. P equals 2/7 t. If you do 1 divided by 3.5, that's what you get. You can also do it this way. 1 divided by 3.5, like we said, 1 divided by 3.5. You can do 1 divided by 3.5 is 3 times 2 is 6 plus 1 is 7/2. So 1 divided by 7/2, remember dividing fractions, we multiply by the reciprocal. 1 times 2/7, that's where the 2/7 came from. Because if we use a fraction instead of 3.5, that's how we get 2/7. So that's probably why they gave us a fraction at the beginning. Because a fraction answer, 2/7 is a complicated decimal, but 2/7 is an easy fraction. So our linear equation is going to be P equals 2/7 t. And it wants us to complete the table below, and we are allowed to use a calculator. So they told us what the time is going to be. So pages equals 2/7. This time is 0. And then we substitute the times 5 times 10, 2/7 times 15, and P equals 2/7 times 20. And so what we need to do now is we need to take some time. 2/7, well, this one is easy. 2/7 times 0. So in 0 minutes, he types 0 pages. In 5 minutes, he types 10/7 pages. Or you can say 1 3/7. In 10 minutes, he types 27 pages, and that is actually 2 6/7. In 15 minutes, he types 30/7 pages, because 15 times 2 is 30/7, which is 4 2/7. In 20 minutes, he types 47 pages, which is 5 5/7. So we have the equation. Hopefully you got the right equation. Hopefully you substitute correctly and got these pages. Next thing we need to do, remember, after we have our chart, turn them into coordinates. And so I'm just going to put the coordinates next to the chart because that's where I have room. The coordinates, we have 0 for t, 0 for pages. 5 for time, 1 3/7 for pages. 10 for time, 2 6/7 for pages. 15 for time, 4 2/7. 20 time, 5 5/7. So we found our equation. We use the equation to finish our chart. We use the chart to make our coordinates. Now we're ready to put the coordinates on the graph. So first one was just 0, 0, so that goes right there. Then we have 5 1 3/7. So we go to 5 1 3/7 is going to be close to about there. 10 is here. 2 6/7 is going to be pretty close to 3. 15 is here. 4 2/7 going to be about right there. 20 here and 5 5/7 is going to be about right there. And that's what your graph should look like. So this is what my work looks like. Your work should look just like mine. We found our equation by solving a proportion. We used our equation to finish a table, and we used a table to make coordinates. Sorry, here are the coordinates. And we used the coordinates to make our graph. Hopefully you got the same answers I did. Part D. There is a D on page 108. About how long would it take Juan to type a 5-page paper? Well, this is where our graph comes in handy. How long would it take Juan to type a 5-page paper? We can use our graph. There's 2 ways to do this. One way is to use our graph and kind of connect the lines we have. Because this is a linear equation, we should be able to connect the dots and make a straight line. And then what we do is we find How long to take 5 pages? So we go to 5 on the page side. We go across. And if you look right here, that's where the 5 hits the line. So how long will it take Juan to type 5 pages? Looks like it is the dot is in between 17 and 18. So it hits the graph between 17 and 18 minutes. So about how long would it take Juan to type a 5-page paper? Between 17 and 18 minutes, because we looked at the graph. If you look at the graph, that's where 5 pages lines up with the graph. So that's one way to solve this one with how to find a 5-page paper, by looking at the graph. The other way is to use the equation. Remember, our equation was P equals 2/7 T. The other way to find it is to take the equation, instead of we're looking for T because we want to find how long, but we know it's 5 pages. So we do P, when P equals 5. So we say 5 pages equals 2/7 T. To solve this, we multiply by 7/2, because 2/7 is the reciprocal of 7/2. It cancels, so because 2/7 times 7/2 is just 1, so we just get T. But we want to multiply by 7/2. Multiplication property of equality tells you to do the same thing both sides. 7/2 times 5 is 35/2. So, and 35/2 is actually 17.5. So when P is 5 pages, time is 17.5 minutes. So the graph was accurate because we said it would take between 17 and 18 minutes. That's about. When we looked at the graph, we found the estimate, the about. But using the equation and saying 5 equals P, we find the time is exactly 17.5 minutes because we use the equation. So when you're finding out answers, you can look at the graph. Looking at the graph will help you, but it's not always exact. Using the equation gives you the exact answer. That's why another reason why these equations are valuable, because they give you more specifics than what your eyes might be able to see on a graph. So hopefully you got all that. If you did not get that on your own, hopefully you understood what I just showed you. But let's look at exercise 2 that you did and see how you did on that one. Exercise 2 is talking about Emily, and she's painting. And remember, she's painting at a constant rate. The constant rate is important. No constant rate means we can't do a linear equation. It says constant rate, so linear equations are good for us now. She can paint 32 square feet in 5 minutes. What area can she paint in T minutes? Okay, what area A? So we need to write a linear equation with 2 variables that shows the number of feet Emily can paint in any time. So for any time. So that's why we need to have area and time. So what we know she does 32 square feet in 5 minutes. What we want to know is what is her area, what in any time for any T. So we know 32 and 5. We want to know A over T for any area in any time. And remember, it says constant rate, which means it's constant. It never changes. That means this and this have to be equal. So make them equal to make an equation. And then if you want it to be an easier equation to deal with, change that proportion equation by multiplying both sides by the denominators to simplify it. The t's cancel on the right side, the 5's cancel on the left side. You get 32t equals 5a. 32t equals 5a. And because we really just want the area, the area is what we care about. We want to isolate the a. We do that by dividing by 5, because 5a divided by 5 is 1a. But the division property of equality says we need to do both sides divided by 5. So what we get is we get 32 over 5 times t equals A. And that is our equation for how Emily paints. A equals 32 over 5 times T. So that's what we're going to be using in our chart for part B when we complete the table below. A equals 32 over 5 times T, because that's how Emily paints. So they even told us the T's again, so now all we have to do is fill in the chart. So for the first one, we're going to do 32 over 5 times 0. For the next time, they gave us a 1, so that's 32 over 5 times 1. Then they gave us a 2, and then a 3, and a 4. So we just substitute. So let's solve these. It says use a calculator and round answers to the 10th place. So we can do that. I don't need to do this for the first one because I know 32 fifths times 0 is just going to be 0. So my coordinates are 0, 0. For number 1, I need to do 32 over 5 times 1. Well, that's just 32.5. But I think it wants it to give us in decimal form. So let's do 32 divided by 5 is 6.4. So my coordinates are 1, 6.4. And then I need to do 32 divided by 5, which is 6.4, times 2. So I type that in my calculator, I get 12.8. So my coordinates are 2 and 12.8. Then I do 32 divided by 5 times 3, and I get 19.2. So my coordinates for 3 minutes is 3 minutes and 19.2 square feet. And then for 4, I do 32 divided by 5 times 4 this time. So I get 25.6, which gives me a 4, 25.6 for my coordinates. So in part A, you should have found this equation. For part B, you use this equation to complete the table, and you found your coordinates. And I'm guessing part C on the next page, yep, they want us to graph the coordinates. So I'm going to put my coordinates next to my graph, and I'm going to start putting them on the graph. 0, 0, right there. 1, 6.4, well, here's 1 for time. 6.4 is going to be about right there, because remember this is 6, 8, so 7 is in the middle. So 6.4 is going to be about there. I need 2 and 12.8, so here's 2, and I go up to about 12.8, which is going to be about right there. 3 and 19.2, so I just go 3 on the T. I go up to 19.2, going to be about right there. 4 and 25.6, here's 4, go up to 25.6, going to be about right there. So the graphing is actually pretty easy if you have your coordinates. If you know your coordinates and you know how to read an XY axis, the graphing goes pretty quick. So there we go. There's our graph. And then for part D, it says, about how many square feet can Emily paint in 2.5 minutes? So 2.5 minutes. Remember, there's 2 ways we can do this. We can look at the graph and look at about 2.5 minutes. So what I'm going to do is I'm going to connect my line, connect my points on the graph. Remember, this was a linear equation, so I should get a straight line when I connect all my points. And then if it's 2.5 minutes, that's 2.5 minutes on the time. So I go to 2.5, which is right here, and I go up until I get to my graph, and I hit right there. So I'm going to say it hits 2.5 hits right about there. So I'm going to say in about 2.5 minutes on the graph, that's about 2.5 minutes. I hit the graph and I go left, and that looks like in 2.5 minutes she will paint 16 square feet. So I'd say about 16 square feet in 2.5 minutes, according to the graph. Now, the other way to solve this is to use the equation we got right here in part B. A equals 32 over 5 times t. So our other option is when t is 2.5, we use A equals 32 over 5 times t. So we do 32 over 5 times 2.5. So what we do is let me turn that into an improper fraction. This turns into 32 over 5 times 5 halves. So we got 32 over 5 times 5 halves. Well, we can do that. The 5 divided by 5 just turns into 1. The 32 is actually 2 times 16. So I break the 32 into 2 times 16, and I get 2 divided by 2, which cancels. So you can see when I simplify everything, I get the answer 16. So according to the graph when we looked at it, we got 16. And when we substituted into our equation, we also got 16, which just confirms that in 2.5 minutes, she can paint 16 square feet, because that's what we got from the graph and from the equation. So that's exercise 2. I hope you did well on that one. I know the fractions might be confusing you a little bit. You might be struggling with the fractions. That's okay. If you need a reminder about how to do fractions, remember you can reach out to me. We can have a little meeting about how to multiply and divide and add and subtract fractions and all that fun stuff if you've forgotten it from previous years. But let's take a minute and check your work on exercise 3 to see if you did that one correctly. So exercise 3 starts at the bottom of page 109, and we're talking about Joseph going for a walk. So it says Joseph walks, and here's the important part, at a constant speed, which means we can do a linear equation because linear equations have to be constant, so we can do the work for this. So we always check to make sure if it says constant speed first. He walked to a store that is 1/2 mile away in 6 minutes. How many miles m can he walk in t minutes? So we need an equation for how fast he walks. And that's what it's asking us to do in part A. Write the linear equation. So let's start again with what we know. We know that he can walk 1/2 mile, 0.5 miles in 6 minutes. We want to know how many miles m he goes in t minutes. So we have we have the ratio we know, the ratio we want to know. To find this, and we need to turn this into an equation. Well, we can do that because we know it's a constant speed, so our two rates have to be equal because it's constant. It never changes. So they are equal. So we take 0.5 over 6, make that equal to what we want to know. And again, this is our proportion, two fractions that are equal. Let's simplify our proportion like we've been doing for a couple weeks now. Multiplying by the denominators on both sides to simplify it, because we can cancel the 6's on the left and the t's on the right. And we end up getting 0.5t equals 6m. And remember, it's the miles he walks we care about. So we want to isolate the m. We do that by dividing by 6. And with division property of equality tells us to divide by 6 on both sides. So now you have 0.5 divided by 6. Let's actually solve that because I think that'll be easier to solve. Well, you know what? It's that funny decimal. So instead of having that be extending decimal, let's do 1/2 divided by 6. Let's write it as a fraction because the decimal does not look friendly. Let's write it like a fraction. 1/2 divided by 6. Dividing fractions, remember we multiply by the reciprocal. The reciprocal of 6 is 1 over 6. So we get 1 times 1 is 1, 2 times 6 is 12. So 1/2 divided by 6 is 1/12. So we get 1/12 t equals m. And that is the equation for how far Joseph walks. That will tell you how far Joseph walks for any t you want. So I'm guessing we're going to have to do another chart for part 3b. And yes, there's 3b, and we have to do our chart. So let's put the linear equation we found in part A, m equals 1/12 t. And let's solve it to complete our chart. And again, they already told us the t's they wanted us to use. So all we have to do is substitute. For the first one, it's 0 minutes, so we do 1/12 times 0. Then we do 1/12 times 30 minutes, 1/12 times 60 minutes, 1/12 times 90 minutes, 1/12 times 120 minutes. Now you just need to solve. Well, the first one's easy. 1/12 times 0 is 0, so our coordinates are 0, 0. 1/12 times 30 is 30 over 12, which you can simplify. 30 is 6 times 5, and 12 is 6 times 2. So the 6 divided by 6 is 1, and we keep 5 over 2, which is also 2.5. I'll write both of those, 2.5 and 5 over 2. So we can do t is 30, and m would be 2.5. 1/12 times 60 is just 60 over 12. And if you know your math facts, 60 over 12 is just 5. So when t is 60, m is 5. Those are our coordinates. Then 90 times 12, 1/12 times 90 is 90 over 12. It's probably going to be 7.5, but let's check it. Let's do 12 is 6 times 2, and 90 is actually 6 times 15. So that gives us 15 over 2 after we cancel the 6's, which is 7.5. So 90 is the time, and 7.5 is the miles. Again, we're just checking your work. That's why I'm going a little bit fast. You should have got all of this stuff when you were multiplying. You could have used a calculator. You could have multiplied the fractions. If you had trouble with the fractions, remember, ask me for more help. I will help you with how to multiply these fractions quickly. For the last one might be the easiest one. 1/12 times 120 is 120 over 12, which just simplifies to 10 miles. So we get 120 minutes and 10 miles. So those are our 5 coordinates. So we came up with an equation in part A. We did the chart and the coordinates for part B. And now I'm pretty sure we have to graph the coordinates for part C. And yes, there it says part C, graph the data on the coordinate plane. So our first coordinate was 0, 0. So that goes there. Then we had 30 minutes and 2.5 miles. So we go 30 minutes. And about 2.5 miles will go right about there. 60 minutes and 5 miles. 60 minutes and 5 miles. 90 minutes and 7.5 miles. 90 goes up to about 7.5. 120 minutes and 10 miles. So 120 minutes right here to the 10 right there. And we graphed our coordinates. Graphing is really the fastest one. Okay, let's look at part D now, because I'm pretty sure, like they said, that we're going to want us to use the graph to solve another question. It says Joseph's friend lives 4 miles away from him. About how long would it take Joseph to walk to his friend's house? Well, remember, we could do this 2 ways. We can look at the graph, or we can use the equation. Let's start with the graph. I'm going to connect my dots because this is a linear equation. I should be able to make a straight line if I did my graph correctly. And yeah, there we go. There's my line. And then I'm going to find, it says 4 miles. So here's the 4. Where does the 4 hit the graph? Hits it right there. So I'm going to say, how long would it take Joseph to walk to his friend's house? Between 40 and 50 minutes to walk to his friend's house. Now, that's just an estimate. I know it's between 40 and 50 because hit the graph and I went down, I'm between 40 and 50. If I want an exact number, I'm probably going to have to use the equation. So miles is 4 miles, so I'm going to say m equals 4 miles. And I'm going to use the equation I got in part A, which remember, m equals 1/12 t. And this time the m is 4, so I get 4 equals 1/12 t. And I'm going to use the multiplication property of equality. I'm going to actually multiply by 12 because 1/12 times 12 cancels and just turns into 1t. But the multiplication property of equality tells me I need to multiply by 12 on that side. So 12 times 4 is 48. So I'm going to say 48 minutes is the exact answer according to the equation. But you can use the graph to find an approximate answer. You can use the equation to find an exact answer. Both ways will work. Both ways will get you there. That's the beauty of linear equations. That's the beauty of graphing. It's a way to find an answer exactly, and graphing is a way to visualize your answer and to see why it makes sense. I believe that was the end of your exercises, and I hope you followed that well enough. I hope you tried it yourself and you did a pretty good job. If you have any questions about it, remember, ask me. On the next page, page 111, is the lesson summary, just talking about constant rate. Remember, you start with a constant rate, you find an equation, then you do a table or a chart, and then you graph. Those are the 4 things we did today. We found a rate, you made your equation, you finished a table or a chart, and then you graphed. 4 things we did today. I hope you know how to do all 4. If you are struggling with all 4, couple options. Let's look at the exit ticket we'll talk about last. Let me slide that to the back. There is a homework helper on page 115 and 116, and I'm guessing probably, yes, 117. 3 pages of homework helper, 115, 116, 117, that will give you more examples about how to find the rate, find the equation, do the chart, and do the graph. Remember, those are the 4 steps. Rate, equation, chart, graph. If you need more help with that, look at the homework helper or give me a message, get me a message, and I will help you do a little bit more with a little bit more practice. But after you look at the homework helper and you feel comfortable, you have the problem set on page 119, and there are 4 more questions where you're probably going to have to do 119 and here 120 and 121 are all your problem set. And remember, it's 3 pages because the charts and the graphs take up a lot of space. I mean, there's a chart on 119, there's a big graph on page 120, and there's a chart and a graph on 121. So I know it looks like a lot of pages, but really it's not that much. Remember, we're just doing 4 things: rate, equation, chart, and graph. Rate, equation, chart, and graph. That's all we're doing. So this is the problem set. I want you to try your best on it. Remember, my answers to the problem set are posted on the Google Classroom so you can check your answers with mine. Remember, I'm also available to help you anytime. You just need to ask and I'll help you. I'll do 1 or 2 or 3 or all the problem set questions with you to make sure you understand. You just have to ask. When you finish your problem set and you check all your answers with mine, go back to the exit ticket from page 113, and it's going to ask you to do those same 4 things: rate, equation, chart, and there's no graph on this. So just rate, equation, and chart. You don't even have to graph for the exit ticket. But when you're done with the exit ticket, take a picture of it, turn it into the Google Classroom assignment so that I can make sure you know what you're doing. So practice on the problem set, check your answers with mine when you feel confident, and maybe after you've asked me for help, do the exit ticket to show what you learned. And that's the end of the lesson. Work hard, do your best, have fun, and I'll see you next time.